On a windy day, the top of a skyscraper can sway back and forth by several feet. That's not damage. It's the design working exactly as intended. A building that didn't bend would probably crack apart instead. But there's a catch. The people inside can feel every inch of that motion. In a 100-story tower, that sway can get bad enough that people at their desks start to feel seasick. So how do engineers stop a 1,000-foot steel tower from swaying without making the whole structure rigid? Every tall building is basically a stiff diving board standing on end. Wind pushes it, it bends, then it wants to spring back. That makes it an oscillator. And oscillators have a nasty habit. Pushed at just the right rhythm, their swings get bigger, not smaller. Gusty wind is random, but randomness is enough to eventually find a building's natural rhythm and pump energy straight into it. Left alone, the structure's own steel and concrete will damp that motion out. Eventually, engineers needed something faster. The fix is a device called a tuned mass damper. The idea sounds almost too simple to work. Put a giant weight near the top of the building. Let it slide slightly out of sync with the sway, and let friction quietly bleed the energy away. When the building sways one way, the mass pushes back the other way. A shock absorber for an entire skyscraper. Except instead of a small hydraulic piston, this shock absorber can weigh as much as a jumbo jet. Some buildings use a solid block riding on rails. Others hang a massive pendulum from the roof and let gravity do the tuning. Either way, the mass moves only inches, but that's enough to cut a building's sway by 30 to 50%. The hard part isn't the concept, it's the tuning. Get the frequency slightly wrong and the damper does almost nothing. Shynex waiter said. Get it right, and a few hundred tons of steel becomes the reason nobody at the top even notices the wind. This isn't only about comfort. Uncontrolled sway can fatigue structural connections over decades and throw off elevators and plumbing risers. It's not just buildings either. Long-span bridges use similar dampers. London's Millennium Bridge famously needed one added after opening, when the crowd's footsteps synced with its sway. It's a strange bit of engineering logic. The way to stop something from moving too much isn't to make it stiffer. It's to give it something else to move with. Next time a very tall building feels completely still on a windy day, remember, somewhere above your head, a few hundred tons of steel is quietly doing all the work. Thanks for watching.